Okay, so keep going. Number 6 for section 2.3. Now, this number 6, they ask you to use synthetic division. Now, what's the synthetic division? It's the kind of shortcut compared with the long division. Now, you may try the long division, right? And then you use subtraction for the long division. So I show you the long division here. And then how can we make a shortcut for this long division? So everything we need is the quotient and the remainder, right? The question itself already give you the dividend and the divisor, so we don't need to work on these two things. All you have to find out is what's the quotient and what's the remainder. Now let me erase those marks first. Okay, so let me show you. So one more time, the question itself, they give you the dividend and the divisor. You don't need to find them. But you do need to find the quotient. How you find the quotient? That's one thing. So when you find the quotient, you want to write down your answer for the quotient. Now, when you do the long division, I want you to pay attention on the long division is too long. Why is too long? Like you have same s cube, s squared, and the x. We understand by the descending order. The degree by the descending order. It need to be x cubed, x squared, x1 degree, x0 degree. So actually, the synthetic division, if we say there's a shortcut, you may just get rid of those, waste the time, right? I always say mathematicians, they are all lazy. As long as you can save your time, why not? So let's try this way. Okay. So how about we only write down 3, 13, 8, negative 12. 3, 13, 8, negative 12. See? This smart idea. And then right after you multiply, you need to subtract. You need to subtract so many times. And that's one thing, right? You need to subtract. And another thing is you always want to subtract to make sure what do you want to get rid of. You want to get rid of 3x squared. You want to get rid of the 7x squared. You want to get rid of the next 6x. So basically, how you find this 3 is always depends on this number, right? So this is 3, then this is 3. If not 3, then you choose number, change the number. So if this is 3, this number, if this is 1. So these two numbers multiplied need to be 3. They are just the same thing. Why you want to write down same thing twice? See? So what's the shortcut? You understand this is 3? Yes, you need to write down 3. Yes, for sure. And the next number is 13, right? But how you make a 7x squared happen? How you make a 7x squared? And this 7x squared, do you need to write down twice? You don't. So first you have 3, you want to get rid of 3. And the next you have 7x squared, you want to get rid of 7. And the next you have negative 6x, you want to get rid of negative 6x. And then the end you have negative 12, you want to get rid of negative 12. It becomes 0. Okay, so your remainder is 0. So from here, you find out that there are so many things duplicate, which you don't want to write down too many times. Okay, so let me erase and show you how you can save your life here. Let me erase. Okay, so if you take a look, you don't want to write down so many x. So therefore, there's no x here. No x here. Okay, this is x cubed, x squared, x, and no x. You don't need to write down that. And you want to write down your answer 3, 7, negative 6. How you have 3, 7, negative 6 happen? That's very important. But you can see that 3 came from your original question. So for sure, you have 3 here. Okay? So first step, you write down 3. Next, how you have 7? Because 3 times 2. Okay? And the 3 times 2, you want to have negative. So therefore, you want to have 3 times negative 2 is better. So the other thing very important is, since we don't want to write down subtraction so many times, how about we just make positive 2 become negative 2? Do you think that's better? So we divide by negative 2, or we multiply by negative 2. Okay? We divide by x plus 2. But when we are doing the synthetic division, we multiply this number by negative 2, not a positive 2. You always multiply negative 2. Make sense? So it's negative 2. So once you have negative 2, then you have negative 6. Once you have negative 6, means you don't subtract because this negative already there, right? Negative 6. When you have positive 6, you have take away positive 6. But right now you already have negative 6, then you plus. So between these two lines, we have plus. We no longer have subtraction. We change all the subtraction to become addition. And we distribute this negative sign inside. Okay, we distribute the negative sign inside. So you plus, you have positive 7. See positive 7 here. Yes? Okay, so you have positive 7. Okay? And how you have negative 6? Because you distribute the negative 2 to your 7x times x, so you have negative 7x squared, right? You distribute negative sign. And the 7x times 2, but we change it to times negative 2, so you have negative 14. Okay, negative 14. Negative 14. So how you have negative 14? Because you have 7 times negative 2. And then you keep going, plus them together, you have negative 6. And the negative 6 times negative 2, you have positive 12. And then these two plus together, negative 12 plus positive 12, then you have 0. Now, this 0 is the remainder. So, let me show you each step one more time. And hopefully you can just remember the steps. Okay. So, number 1, you change plus x plus 2 to become minus 2. That's step 1. Okay, step 1. And the step 2, you drop 3 here. After you drop 3, so that's step 2. Let me write down that step 2. Okay. And after you drop that, then you multiply. Negative 2 is 3. and then you have -6. And then you plus these two together, you have 7. And then you repeat the same procedure, -2 times 7, you have -14, and plus these two together, you have -6. So after that, last step, we change this color. You have -2 times -6, so you have +12, and then you plus these two together, you have 0. Now one thing, keep in mind, this 0 is the remainder. This is remainder. Okay. And what's the quotient? Quotient is here. 3x squared plus 7x minus 6. Okay, so let me erase those marks and then let me explain one more time for you. Okay, so let me erase. Because this is the first time you are learning synthetic division, I would like to show you one more time. So after all the explanation, right now I'm not going to explain one more time, but I'm going to show you the method one more time. Okay. So first, you copy the question, just copy the coefficient. You only copy the coefficient. Okay. And then you change +2 to become -2. Or you can say x plus 2 equals to 0, you solve for x. X is -2. That's very important concept. You solve for x plus 2 equals 0. So means when x equals -2, x plus 2, the divisor will be 0. After you find out the divisor, one more time, I want to talk about the synthetic division only work for when the divisor is first degree. When the divisor is more than 1 degree, then we don't have shortcut. Like this one, second degree, no shortcut or no synthetic division. Okay, when you have more than 1 degree, then there's no synthetic division. Only when you have only 1 degree, or we say binomial, then we create this synthetic division for you. So you, after you set up divide by -2, actually we try to times -2, okay? Times -2, times -2, and the plus. You times -2, do that. Oh, let me show you the, okay. Okay. So times -2, then you goes to here, right? Times -2. And then plus, then plus. Let me make the marker even better, okay? Okay, so times -2 and the plus these two number times -2 plus these two number times -2 plus these two number. Okay, so always like that. And if you feel this method kind of too hard for you, that's fine. You can try to compare with this. I said the middle part. So this one you make an upside down division. Okay, we do the same thing, except we just don't want to write down x cubed, x squared, x. So no, just coefficient. Okay, and the change +2 become -2. and then you put your quotient here. 3, 7, -6. Let me change color because this quotient we want to use other color. So the quotient, I use green color. How about that? Okay. So the quotient is here. The quotient also is here. You see that? Okay. So that's why we don't want the we don't want the long division, because long division wastes our time. We write down the same thing so many times. The quotient is already there. And why you want to write down this. Or basically we keep 3, 7, -6 as a quotient. Then you don't need to write down quotient one more time, right? It's the same thing. So quotient created from these 3 numbers. And how can you have these 3 numbers? Because these 2 numbers subtract. And we don't, when we say subtract, basically is plus negative. So when we change to negative, then we plus negative. See, we plus negative, right? We plus negative. Wow, the same color. Okay, let me change to other color. Okay, we change it to pink. Okay, pink. So when we plus, the negative number is here. See? Okay, I don't want to block the number 8. So plus the negative number. And here, these 2 numbers plus -14. So plus -14, right? And then these 2 numbers plus -12. So this one. Okay, so negative become positive here. And this will be the remainder. So this is the remainder. And this is a quotient. This is a quotient. This is a quotient. And if you understand this, then we simply make the middle parts shorter. Okay, so how we make this middle part shorter? We simply make this one longer. Okay, this one longer, and put this 3 here with the quotient. Okay, put this one up, -6, and everything goes to here, -14. This one go up, +12. Okay, you push up to become, you line up everything. So you may figure out from middle part to the synthetic division, or you may want to, if you will directly follow the steps for the synthetic division easier for you, then you can do that. And if you still have questions, we may talk about it during the class time online. Okay, so this is number 6, and you understand the quotient. Quotient is this number. Quotient is these 3 numbers. Okay, so number 7, I show my work here. This is the middle part. You may compare this one with the long division, more similar to the long division. But how we try the synthetic division, because right now the divisor is only 1 degree, so we can try the synthetic division. This one I didn't show the synthetic division. Let me see. I can show it here. I don't have enough space. Okay, I can do it here, right? Make it longer. So this one I copy from here, okay? 1 minus 13 plus 0 plus 0, take away 120 plus 82. Okay? And x plus 3, I solve for equal to 0, therefore x will equal to negative 3, right? So I multiply with negative 3. Now I drop down this one here. Negative 3 times 1, negative 3, plus together, negative 16. Negative 16 times negative 16 times negative 3, it becomes positive 48. Plus together you have 48, and then 48 you multiply with negative 3 again. So you are going to have negative 144. Negative 144 plus together become, still negative 144. So we have negative 144. Now let me change the color. So negative 3 multiplied with negative 144, I have positive 432. Plus them together, I have positive 312. Now let me change one more color to purple. Multiply. Then I have negative 936. Plus together, I have negative 858. So if you use long division, you may have similar number. Okay, so I copy all the numbers from where? From this. Okay, this is similar to the long division. And then we just make a long division simplified. So where is your quotient? Quotient will be up to here. Okay, and the divisor, this is the divisor. Sorry, this is the remainder. This remainder, this quotient. Okay, and this one, basically x minus negative 3 is 0. That's the divisor. Divisor is x minus negative 3. Okay. Next, number 8. Number 8, you may directly try the synthetic division, but you want to rearrange. Start from the highest degree. You have x cubed plus 3x squared, take away 4x plus 5. Okay, you want to rearrange to here. Okay, and then you have negative 1 for, you have negative 1. Oh, I need to change color. Okay, so you have negative 1. You have negative 1 here. Okay, so first you drop down negative 1 and then multiply. These two multiply and then goes to there and then plus, and then these two multiply goes to here and the plus. These two multiply goes to here and the plus. Always follow the same procedure. And why we do that? You consult with this one. Okay, it's the same idea, just we made a shortcut. Now, after that, you write down your quotient and your divisor and the remainder. Right? And this remainder. So this is number 8, and keep going number 10, or number 9. Number 9. Now, I want to talk about that. We keep changing the sign when you want to divide, like +1 become -1. This number we call it, we give it a name called K. Why we call it K? And then number, which question? Number 7? Number 7, K equals to -3. K equals to -3. Okay. Number 6. Number 6 here, K equals to -2. Just the opposite sign of the number. Okay. So number 9, the number you want to use under synthetic division, this is K. Okay. So I think a synthetic division is not too hard right now, and they already say you need to use -2. So it means x minus K is the divisor. Okay, so x minus -2 is x plus 2 is the divisor. So this x minus K is the divisor. Now remember earlier I asked you to memorize a polynomial. If you divide by a divisor, then you can write down as divisor multiplied with quotient and the plus the remainder. So here, let me erase those marks here. Actually, this question already show you this is a divisor and this is quotient and the plus remainder. Now because our quotient, because our divisor is 1 degree, so our quotient need to be just a real number, no degree, 0 degree. So just R. Otherwise, if you want to write down Rx, but this x is 0 degree. Okay. So this is our polynomial function, and you can do that. Okay, so this question number 9, I'm going to teach you something very, very important. We call it remainder theorem. Remainder theorem is kind of surprise for you, a very interesting result. Okay, so this question we can use a synthetic division. This is synthetic division. Okay. So they give you K equals to -2, means the divisor is x minus K. So x plus 2 is the divisor. But when x plus 2 is the divisor, we use -2 for the synthetic division. We multiply with -2. Okay. So here is the quotient. So this question you can say the function f of x equals to, let me rewrite. So let me start all over to write the function, the polynomial x cubed minus 5x squared take away 12x plus 5. If you try to divide by a divisor x minus -2, okay, x minus -2 because k is -2, and then you are going to have a quotient x squared minus 7x plus 2. Here we divide, and what's the remainder? 1. Because the divisor is 1 degree, therefore there's no degree here, 0 degree. So that's what we learned earlier up to here. But right now, very important thing called remainder theorem. Remainder theorem is telling you, if you understand this theorem, basically you don't need to use division to find the remainder. So any other way, I can easily find the remainder without use division. If you want to find the quotient, then you do need to do division. But if I only ask you to find the remainder, you don't need to do division. Why? Okay, why? But right now, let me write down this one. This is f of x, right? Let me tell you what's the remainder theorem. K equals to -2. So you input this k to your function f. So you are going to have k cubed minus 5k squared take away 12k plus 5. By doing this, you are going to have k minus -12 is k, right? K minus k times whatever the quotient and plus this remainder. Make sense? Okay. So basically, remainder theorem is telling you, if you input the k to the function, you are going to have 0 times the quotient. So you don't even have to find the quotient because 0 times quotient is nothing. And the only thing you have is remainder. And you understand this is 0, right? This is just the 0. So it's gone. This is 0. So do I just give you a formula? See, this is the formula. Fk equals to R. Fk equals to the remainder. So this question, if I didn't ask you to find out what's the quotient, I only ask you to find the remainder, then what you do, you use your calculator, input the -2 to the x, and use your calculator. You can easily find. You plus them all together is 1. So remainder is 1. So this is a very surprising result and very interesting theorem. You want to always use it. Yes, if you say, oh, synthetic division is easier, you may try synthetic division. Okay. Otherwise, I will say you may just input and then you can do it. But this method is very important for you to test if there is remainder or not. Say if remainder is 0, means if remainder is 0, means you may evenly factor the polynomial with the divisor. Okay, so we are going to talk about more concept with the remainder theorem to use somewhere else. Not only use it to find the remainder. We want to use the remainder theorem not only find the remainder. We want to test if we are able to factor by the divisor or not. So I'm going to end this video right now, and then next video we are starting from number 10, and then we try to apply the remainder theorem to something more important. So see you next time. Bye bye.